Okay, we'll maybe just throw a couple, three examples up there. Eventually, when you have this many papers handed in, handed out, and I get it, there's 100 and, well, your tables have more than 103 on there. I think, are we up to like 117 maybe, somewhere down here? Okay, so obviously your table is a little more complete because the copyright on this is 91. So up on the wall. But one of the nice things for having that is you can see that from almost any. Some of the more important aspects you can just see from one side to the other. The atomic number, of course, the element, and you can see which block it's in, which period it's in. But the atomic masses, that might be a little different along with its charges. Next week, when we return, then you're going to have your calculators back again. Okay? We'll be doing some more work in that regards with, or no, I'm sorry, that's not right. We need to move on to dot diagrams. So no, the calculators can stay in your locker, home, backpack, backpacks, whichever way you want to look at that. Then when we get to chapter 7, naming compounds, that's a big one. And everything from here on out, okay, is a review of what you had done 2 years ago. Okay, uh, chapter 3, your atoms and moles. That was probably some new material, adding together atomic masses. I think you did as freshmen. It was just something that you would try for practice and naming the compounds. You never knew what Avogadro's number was or how to do exponents, but that's why we take these in phases. So, moving forward, sometimes maybe it's better to get your input on what you'd rather see done as far as a Bohr model, a configuration, or um, quantum numbers. One of the things I want you to think about is, was there quite a, we talked about closing that gap. Now, do we feel comfortable now that we've closed that gap? Compare that to what, maybe September 3rd, maybe not that far back. Maybe about the 8th or 9th when the first time you saw the slide rule again and these configurations and oh my gosh, this is awful. I don't know if that's anybody's perception in here, but just think of how far you made it forward since then. But I'm not going to stand up and waste your time if you don't feel you need to do some examples, but I'll just throw one or two up there, and then beyond that, it'll be up to you whether you want to see some more. Okay? So what part about this do you think is the most difficult? We'll go from there. We're all good? So I don't have it copied. I wouldn't give you the exam today, but what you're saying is you'd be ready to go today, and that would be fine. But we're not going to, like I said, the bell's been rung. We're not going to try to unring it. So, all right. What do we need bonus questions for? There's no math involved here. That's not really. One of the things that we did learn as freshmen, okay, when you're looking at these periods or energy levels, if you really, and you really should be a little more, let's say, precise now that you're juniors, especially 2 years from now, when some of you are sitting in a freshman chemistry class, is that when you look at the first energy level, we only holds two. It's hydrogen, helium. Then the second energy level only holds 8, which is your 2s2 block and your 2p6. And all this information is presented on the periodic table, but it's a lot easier to see with what tool can you use besides the table? Say that again. Slide rule lays it out for you if you follow that. I'm not saying it's going to be a given for everybody, but yeah, it is possible to make mistakes, especially if you're going too fast. So then we would say the third energy level, by looking up there at Bob hanging on the wall, that we would say 8. But that is not correct. The third energy level actually holds how many? And your slide rule tells you that too. Not 8, but rather what? Why are you right? Yeah, I agree. So the fourth energy level can hold how many? See, is this where you need the calculator? Because what does the F block hold? 14. And if the throw that together with the D, the P, and the S, what's 14 plus 18? Don't get a calculator out. What? No, 32. Okay. Part of it's not. This is going to sound wrong when we say it. Um, it's not that you don't know how to do this. You do. But when you're doing inequalities or solving for two unknowns in higher order, when it comes to algebra 2, quadratic formula, all that material, the simple math kind of, I'm not saying it falls by the wayside if it's something you don't use or think about. Oh, geez, it's easy to make them mathematical errors. Simple arithmetic, but maybe that's why you want your calculator. I don't know. Okay, so let's see here. To me, perhaps someone pick a number between 90 and 99. Okay? You! Yeah, what's the symbol for uranium? U. Oh, see? U! Okay? So, all right. So doing the Bohr model for this, that would take quite a while. So we're not going to spend, unless you think you really need, in your slide rule helps you with that. We can certainly do, that'd probably be good practice. So anyway, some predictions that we can make, okay? What is the last energy level that will accept electrons? Now, that's kind of a trick question. Just don't blurt out the first thing that you see. Because first of all, you're going to want to look what block is uranium in. It's in the F block, so there's only 2 periods that the F block is in. It's either what or what. It's either 4 or 5. So if it's on the bottom portion of that, it must be which energy level? It's actually in the last ones are in the 5th energy level. But we're going to go all the way up. What's going to be on the way outside? Well, the slide rule will tell you that. You're going to have how many total energy levels in this? You are right, but why are you right? Because you're going to go all the way up to the 7th energy level. So let's see how or why that is. Okay, so we got 92 protons in the nucleus. And let's see here. I think plus, God, I'm getting older and it's getting hard to see. Does that say plus 5 or 6 in there? Okay, so plus 6. So if uranium forms a charge of plus 6, how many electrons is that? It has 92 protons. That can't change. But the number of electrons can. So if it's a plus 6 charge, how many electrons would that be? Well, what's 6 from 92? I thought someone said 85. Did someone say 86? You said 86? You didn't? Oh, I can't see or hear. Okay, so that's probably a problem. But okay, so yes, 86. So as we do this, we know 1s2. And again, your slide rule helps you with this. So we know we're going to be all the way. And for those of you who are doing this, I really appreciate that. Putting them big curves on there rather than doing something like this. Okay? We already established it's hard for me to see. Okay? You're really compounding the issue when you do this. So one of the things I think, I just can't read it, so it must be wrong, correct? Okay. So 2s2, 2p6. Okay? I'm sorry, I don't think the microphone was on. So hopefully that was recording if someone decides to watch this. Okay. So what noble gas can we use? So when you establish that, we are already up to which atomic eliminated a lot of mistakes that can be made. But again, not everyone wants to do these the same way, and there's nothing wrong with that. Okay? Not everyone can be the running back or the server or setter or whatever, and hitter and passer and whatnot. So, with that, when we're up to element 86, okay, you can make certain predictions. We know radon is in which period? Okay, it's in the 6th period, which block? And that block is full. So what that tells you, look on your slide rule, find 6P6 and go down the slide a little further. So 7S2, then what? That's how many it can hold. Okay? So 8 in 86 gives you 92, so that's got to be right. Okay? Now, right now, you should be able to tell me 2 quantum numbers right now. That's one. That's one of the quantum numbers, yes. And 3. So which variable does 5 go towards? N. So you said 3. Which variable is that? That's L. Okay? So we've got this. N equals 5. Says so right here. M. Oh, excuse me, not M. Wouldn't that be terrible if I switched the order up on your exam? Flip-flop them? See if anyone's paying attention. Do you think, would everyone catch that? What would happen if we had this? Would that be awful? Okay. You'd already established where's the 3 go for which variable. Okay? So now, the only way to determine M is, remember, the F block holds how many? 14. So each of those lines can hold 2. So 14 divided by 2 gives you what? I'm running out of space here. Okay. So remember, M equals a positive and negative value of what L is without skipping over. Okay, so we can find the middle and put 0 there and branch out. That's another way of looking at it. So we said it's a negative value to a positive value of what L was without skipping over 0. Now follow your bus seat rule. So we're going to put 4 of them in there. So M has a value of what? 0, because it fell on this guy right here. And S is what? There we go. Okay. So there's your 3 different examples for that of a pretty big element for the Bohr model, the configuration, and some people just choose to do the configuration and figure out the quantum numbers from that. That's smart. That would be a better way of doing it anyway. You can just skip all these are the only ones you're concerned about anyway. We really don't care about them because this is where you get these numbers from. Okay? Is there anything else? Okay? That didn't take long. Yes. Okay. Well, you got that extra task of just coming in if you're gone. Like I said, that didn't take very long. Because how soon we forget. Oh, we didn't forget. You would have. How come you didn't say anything? All right. Okay. Okay. Bonus one. We should probably do some. We'll do gasoline for some reason. I think about that every time I kind of go by Prairie Junction. I'll explain that in just a moment. Okay. So when it comes to different type of gasoline companies, what's the full name of BP or blank petroleum? Is there O in there instead of U? That doesn't look right either. But you get the idea, right? So we're talking about any BP station or blank petroleum. All right. And then bonus two. Dino. Okay, there's no E, but we call it Dino the dinosaur. Is the mascot for blank. So when you drive by Prairie Junction, they got Dino the dinosaur as their mascot. But what brand of gasoline is Dino the mascot for? That's what we're asking. Okay. We shall catch up with you next time, which would be on Monday. All right.